Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Let's Learn C++. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Today we'll be using Visual Studio Community Edition, which you can download from visualstudio.com. However, you can follow along with whichever editor you like. Make sure to have annotations turned on so you can see the updates I make to this video. Today we'll be focusing on variables, which builds on the previous C++ lesson, so check that out if you haven't yet. If this is your first programming language, I'd strongly recommend checking out my Let's Learn Python series, which teaches you the fundamentals of programming. All you need is the Basics and Object-Oriented Programming series linked to the right, and you'll be well prepared for this C++ series. In the last exercise, we used std:// cout as a way of outputting. This is because std is the namespace that is tied to the function. This line up here that I've included right here, line 2, using namespace standard, allows us to remove the std:// from the front of every cout function call, and allows us to use the standard library without having to include the std:// so we can actually delete that now. This is the equivalent of importing in Python with from my library import star. It'll just bring in all the necessary functions without having to use a namespace or mylib.myfunction. In a later tutorial, I'll cover how to create your own namespaces, as well as when and why they should be avoided at times. For now, know that it means less typing for us, and therefore less arthritis. Also, right here, line 7, you'll notice that I have a /* ... and then a / right here. And these are forward slashes to signify a bunch of code that has been collapsed, a commented bunch of lines. So right here, if we click on this little tiny box, we'll be able to collapse and expand it, and we'll see that we have a bunch of lines of code here that have been commented out, because we can actually use this / and */. This is used to comment out multiple lines, and that's really all there is to it. We can, it allows us to click this little minus sign right here on the left-hand side to collapse and expand that, so we can actually reduce what is on screen. Alright, so what are variables? A variable is how your mom will react when she catches you driving the family car off some sweet jump ramp. A variable is how many girls will see that sweet jump and immediately want to date you. A variable is how big the explosion will be when you land on the ground. Okay, enough goofing around. We know from the Let's Learn Python series that variables are used to store data. But in C++, this is tricky because you must explicitly state what kind or type the variable is. In Python, it would automatically decide it for us. So what data types are there? The ones that come with C++ without importing are char, which is short for character, bool, which is short for boolean, int, which is short for integer, float, double, void, auto, and null pointer. Char is just an individual character. Could be a number, a letter, a new line character, a piece of punctuation. Char is an individual character. Bool is a boolean, which is, we know from Python, true or false. Int is an integer, which is any number without a decimal point. Float and double are numbers that have floating point values. In other words, the decimal point can move around wherever. So we can have like 1.00002, and the difference between float and double we'll get into in just a bit. Auto is a type that automatically determines what the output type is, and we'll see an example in a bit. A null pointer is an entirely different topic altogether, and we'll cover that when we cover pointers themselves. For now, just ignore it. One last thing is that you can have many more different variable types by importing like libraries or data structures or any number of things into your file. Alright, so how do you create a variable? Well, for integers, you just type int x equals 0. And there are 3 different ways you can actually declare a variable. The first one is using the equal sign. The second one is by creating, by declaring the value within a argument or within a set of parentheses. We'll end that with a semicolon. The third way you can create a variable is with curved brackets or squiggly curvy braces. So all these three lines do the exact same thing. I myself prefer the first method the most because it's clearest and it breaks the space up nicely visually. So that's what we will be using to declare variables. Next, let's create another instance of an integer by typing int cars is equal to 14. And then we're going to type int debt is equal to negative 1,000, which is not even close to my student loan debt. Next, we're going to type float cash is equal to 2.32, and then end it with a colon. So that's how you create floats. It's just with the keyword float. And a side note is you don't actually have to include a decimal point and some values like a 0.0 or anything after this. It'll automatically convert it. So you're fine there, even if you just plug in 2. But we'll go ahead and finish that out with a 0.32. Next, we'll create a double by typing double, and we'll type credit is equal to 32.32, and end that with a semicolon. Then we'll create an instance of a character. Char space our variable name space is equal to, and we're just going to put it equal to letter A. Now, side note is that whenever you're creating instances of characters, you have to use single quotes. My cats are going nuts right now. And if you want to create a string of characters, then you have to use double quotes. Next, let's type just that, a string of characters. So we're going to type char star. Now this star is significant because it's basically sending it as an array of characters, which we'll get into when we get into pointers and stuff. Space, and we're going to type sandwich. And we're going to set it equal to, and then use double quotes and type ham. And we're going to end that with a semicolon. And so by adding that star to it, it allows us to create a string of characters rather than just an individual. Next, we're going to do an instance of a Boolean, which is just bool space, and we're going to type does underscore she underscore like underscore me, and that's going to be equal to true. Note that true is all lowercase. After that, we're going to type auto. Now this is a new variable type. Auto determines what type it is after you've set it equal to some value. So we're going to type do underscore I underscore have underscore pants underscore on. And then we're going to set that equal to false. I don't have pants on. I have shorts on. All right. After that, we're going to type auto. Oh, wait, I misspelled false. I can't spell. After that, we're going to type auto and then type blank underscore check. We're going to set that equal to 200.00 and end that with a semicolon. And finally, this last instance is going to seem kind of weird, but bear with me. Type int and then space over underscore 9,000, and we're going to set that equal to all uppercase or caps lock int underscore max. End that with a semicolon. Okay, so what is this int max that we've put in here? Int max is actually the maximum value of an integer. So if we go ahead and just do cout greater than, and then just print over underscore 9,000, and then double greater than sign and endl. This endl, by the way, we haven't covered this just yet, but endl is basically end line. It lets cout know that nothing else is coming at the end of this statement. So it acts slightly different than a new line character. Okay? We're going to go ahead and save that, and then go ahead and debug it by clicking the button Local Windows Debugger up top. It's going to go ahead and compile, and here we go. Then it outputs this number 214-748-3647. This is the maximum integer value possible. So that's pretty cool. We'll go ahead and click continue to finish out the program, and it's done. Notice that it did skip right over these blank lines of code, these comment lines, just fine. So we can continue to leave that commented out, and it will be ignored by the program. When you're creating variables, only use valid identifiers, which are numbers, letters, and underscores. In other words, only create variables using letters, numbers, and underscores. Don't use any punctuation. Don't use any spaces in between words. Otherwise, the program will not interpret it correctly. Also, one last thing is you cannot start a variable name with numbers. Otherwise, it starts getting confused and thinking that you're going to be inputting a hexadecimal number or something as a variable name, which you are not. You can, however, create a variable name as simple as just an underscore letter or, yeah, that's it. So we can go ahead and create int underscore is equal to 5 and end that with colon, and it works just fine. We can even see out that to test it. See out double greater than sign underscore double greater than indel. Okay, save it and test it, and it works just fine. Even something as simple as just an underscore for a variable name works. So that's why you can use letters and underscore as a variable name. I wouldn't ever recommend naming a variable just an underscore, because that will be super confusing. It's undescriptive and it's silly. But know that you can do it. So if you ever get asked that in an interview question or something. All right, so let's go ahead and close out the program. There we go. So keywords. There are many keywords and functions available to you to use in combination with variables when you're either declaring them or after you've instantiated them, that we'll be covering. I'm going to go ahead and comment out this code that we did right here just by typing /* right here and then / afterwards. And now we've got a nice block of commented out code, and we can shrink it down. And beneath it, I'm going to add a couple spaces. And here I'm going to be going ahead and using a function called sizeOf to show you the difference between the size of a float, a double, an int, a character, and so on. On a side note, when we used that int max earlier, you can find the limits of all variables by looking at c++.com and just looking for C limits. That'll list out every possible maximum value and minimum value available to you for floats, ints, doubles, everything. And you can see that they get really big really fast. So we've got like 32,000, 65,000, and then it goes into millions and billions and zillions. All right, but that was just a little footnote I wanted to give to you. So in between our two blocks of commented out code, I'm going to go ahead and add cout greater than size of, and that's all lowercase, and then type in char double greater than, and then end line. And we're just going to go ahead and copy that line and paste it in a few times here. And in place of char for the second one, we're just going to put in int. Then we're going to put in float. Next one, we're going to put in double. After that, we're going to go ahead and put in bool. All right, and let's go ahead and test out our code. We'll go ahead and click the debugger. And now let's look at what's being output. And I'm going to go ahead and shrink this back down so you can see what's going on. First one, char, has a size of 1. That is 1 byte that char takes up. Integer takes 4 bytes. The float takes 4 bytes. The double takes 8 bytes, and the Boolean takes 1 byte as well. So the Boolean and the char both share the same space size. And now we're going to get into something a little bit tricky. So we're going to go ahead and continue the program to close it out. So let's go ahead and copy out this line for size of int. We're going to copy that. And now I'm going to do a cout, and I'm just going to go ahead and add a space in here and endl, just so we have a visual way to break up what we're doing. Next, I want to paste that line we just copied of size int. So now we're going to type size short int. So this keyword of short, space, and then int. All right. And then below that, I'm going to add another line. And then we're going to add long int. And then after that, we're going to add long int. So that's 2 longs in there. Okay. Why am I doing this? Well, short int is a way of getting a smaller version of an integer. It's reduced in size to be very small. Long is pretty much the default, I believe, for integers. It's because they both have the exact same size. We'll see as we run the program. Int and long int will be the same size. Then we're going to try out long int, which is going to be about the size of a double. So it's the size of a double, but it does not include the information for a floating decimal point. So let's go ahead and run the program. And here is the output. So here we have short int. And short int is half the size of the original int. Very interesting. Long int is the exact same size as int. There's virtually no difference there. And then we have long int, which is the same size of our double. Perfect. That's exactly what we expected. Well, when would you use short or long keywords in front of int? You would use it at times depending on the size of the data that you're working with. So if your integers never get above like 30,000, then you'd use a short int. And again, you could use this page as reference for C limits to see just how big of something is. So for instance, short max is the maximum value that a short integer can have, which is 32,767. So if you know your data will never be bigger than that, then you can feel free to use a short integer. Another two keywords I would like to introduce you to is signed and unsigned. Signed can be negative or positive, with 0 as the range's middle point. Unsigned can only be positive and has 0 as the starting point to the range. When we create a variable like int x is equal to -1, by default, C++ likes to make integers signed. So if we added this keyword of signed right here, meaning that it could be positive or negative, then we have a range of between positive and negative 33,000. However, if we replace that with unsigned, then that means that x can never be a negative number. It can get as low as 0 or as high as 66,000. It's basically shifting the entire range to be only on the positive spectrum of values. This may be confusing, so let's go ahead and just try replacing these zeros with actual values. So for here, I'm going to plug in -1 for the signed version, and I'm going to plug in -1 for the unsigned version. And I'm going to go ahead and comment out these lines of code right here that we just typed above, comment those out, and we're going to go ahead and collapse those two. And below that, we're going to type cout greater than x, and then end that with an endl, and then we're just going to repeat that for y as well. So what do we expect to see with this? With signed, it being -1, we expect it just to be -1 because the range dictates that it can be negative. However, the unsigned says that it cannot be negative. So when we type -1, we're going to start from the end of the range and be working backwards. So we expect to see its maximum values. Oh yeah, and let's go ahead and make sure that breakpoint's done. And I just realized we had these variables mixed up, so let's go ahead and replace the first one with x and the second one with y, just so that we have the order correct. So x will be the signed integer, which is going to be -1, and y will be starting from the end of the spectrum and showing us like a very strange high value. And let's go ahead and save that and run it. So x is, of course, -1, which is what we expected, and then y is this incredibly big value right here of 4 billion and something. So why is this? See what I did there? Why is that? It's starting from the end of the spectrum and it's working its way backwards, and so that's the maximum value that it could possibly hold. So that's how the keywords signed and unsigned work. Let's go ahead and continue the program to finish it out. Alright, so let's go into the ranges of integers. And we're going to do that by looking at this last bit of code that I had commented out right here. And these are calling the limit values of the macros in C++. So we have int min, int max, long min, long max, and these are the long versions of integers, and then short min and short max. Let's go ahead and run that code real quick by clicking the local Windows debugger button, and you'll see right here what the values are. So long min and int min are the exact same value. They're both in the positive and negative billions of numbers. And we have the short mins, which are actually in the tens of thousands, or 32,000 and -32,000 right here. However, you can have unsigned versions of these, and these are, I'm going to go ahead and type them out real quick, just adding u to the front of them. Now actually u short min is actually 0, so that's why it's giving us an error saying, hey, this doesn't actually exist. It's because that's 0. So we can actually replace that with 0 itself, and it'll be just the exact same. Because u short or unsigned variables always start at 0 as the lowest possible value, and they go to the max. So let's go ahead and close this program out again and go ahead and rerun it. And now we will see that the range has been shifted, because that's what the unsigned keyword does, is it shifts it over so that the starting point is no longer at -32,000, but instead is 0. And it adds those numbers to the end, where now it's 65,000, which is exactly what we'd expect. So when I spoke earlier about the ranges of the integers, I was speaking in terms of the short versions of the integers. And we are done! Thank you so much for watching. Great job keeping up. Definitely take a few minutes to try out these coding challenges shown here and the debug challenges linked below in the description. You are a brilliant programmer. I'm sure you can do it if you set your mind to it. I will be posting the solutions for these problems after a group of tutorials, but I really want you to develop your own skill set and solutions. There's often many correct answers. Please feel free to leave me a comment below if this helped you at all, and also check out the comments below if you're having problems. Lastly, please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Hit that like button to show some love. Thank you so much for your support, and keep the dream alive.